Good morning. We are starting simplifying rational expressions. So this is really an extension of factoring and looking for the identity element, which is going to be 1, of course, for multiplication and division. So we're going to be doing that. So if we look at this first problem here, you can see that we have a greatest common factor. So that would be the first thing that I would want to do is extract the greatest common factor to see if I have any common factors. So looking at the top or the numerator, they have a common factor of 6. So I'm going to factor out a 6, which is going to give me x plus 2. In the denominator, same kind of thing, except now I have a factor of 9 that I can factor out. And that's going to leave me with a factor of x plus 2. So now looking at what we've just factored, you can see that this will give you the identity element of 1. So basically you can say that that's canceled. And we're still not done because we have 6/9, which can be rewritten as 2 times 3 and then 3 times 3. So we also have a form of 1 right there. So then in simplified form, the answer here would be 2/3. All right, continuing on, we're going to look at problem number 4. When you look at problem number 4, you can see that down here in the denominator, we do not have it in the correct form because we have the constant first and then the variable second. So we want to switch that around. However, when I switch it around, I'm going to have a negative leading coefficient. So I don't want that either. So I'm going to factor out a -1 as I flip it around. In the numerator, I'm going to have a difference of 2 squares. So we need to factor that. All right, so remember they are conjugates. So it's going to be x plus 3 times x minus 3. And then factoring out the -1 and turning that around, I'm going to get an x minus 3 because you have to factor that -1 from both of the terms. So now we look for our form of 1, which we're going to see is right there. So they're both eliminated. And what I end up with is x plus 3 over -1. And if you want, you can rewrite that as -x minus 3. Well, let's look at number 7. In the numerator, we have a trinomial, which again, we know how to factor. And then in the bottom, again, we have that same case again, where the not in correct order and the leading coefficient would be negative. Only this time, we're going to be able to take out more than just the -1 because both have a factor of 4. So we're going to take out -4 when we factor this. All right, so numerator first. Binomial times a binomial. Last term is negative, so that means one's going to be plus, one's going to be minus. We know it's going to be x and x. And I need factors of 12 that when combined are going to give me a 1. So if you look at it over here, we got 1 and 12, 2 and 6, 3 and 4, and there's our combination. We need it to be a positive, so I'm going to put the 4 right there and the 3 here. Then in the denominator, factor out that -4 like we talked about, and that makes x going to be positive minus 3. Again, you can see we're going to have that form of 1 right there. So our end result would be x plus 4 over -4. And a lot of times people try to eliminate this. You cannot, because you would have to do the addition to the x before you could do that. So you cannot simplify that anymore. This would be your answer. Okay, I'm going to remind you, I've been trying to send out messages that each class for algebra will be meeting on Wednesday. You have a specific time, so be looking for that. And on your page, you can see a little camera up at the top. That's Google Meets, so you click on that and it should get you in there. All right, best of luck with simplifying rational expressions.